Hello, students. Your chemistry tutor is here again. Akpeji, Honesty, the chemistry master. Okay, before I will start to attend to this question, ensure you like my video, subscribe to this YouTube channel, and also share to other students. Sharing this YouTube video will increase the knowledge students already have on this topic. And for those who do not have the knowledge, I think you'll be doing them something good, you know, knowing what this theory terminology means. So this is a question before us today, and this question has brought some it has brought some further questions, agitations among students. Now, it was gotten from some past questions, okay? And the question is explain with examples the following: catalytic poisoning, catalytic inhibitor, and catalytic promoter. In any way they ask the question, they may say catalytic poison or poisoning. Okay? It is also called poison, or catalytic inhibitor. It is also called inhibitor, or catalytic promoters, or you call it promoters. Okay? Promoter or promoters, as the case may be. Okay? Now, let's do justice to each of them. Let's talk about catalytic poison. Okay, let's talk about catalytic poison. Catalytic poison. Actually, this is actually a process because of this ing. Okay, because of this ing, it makes it a process. First of all, you know what a poison is. A poison kills, it destroys. Okay, so in a reaction where you add a poison to the catalyst, what happens is that the poison destroys the activity of the catalyst. So a catalytic poison is a substance which destroys the activity of the catalyst to accelerate a reaction. Okay, so that process whereby a substance destroys the activity of a catalyst to accelerate a chemical reaction is called catalytic poisoning. Okay, meanwhile, a substance, okay, a substance which destroys the activity of of the catalyst, okay, to accelerate a reaction. That substance is called what? Catalytic poison. Okay, understand that? Or simply poison. Okay, when you take a poison, you know what it is, you know what it does. The poison does not favor you in your stomach, does not favor your biochemical reaction, okay, taking place in your body. Poison rather destroy, it kills the activity of the catalyst. So this process this process whereby a substance destroy the activity of the catalyst to accelerate the chemical reaction is called catalytic poisoning. Please understand, okay? Okay, that is how you can define a catalytic poison. Now, I want to give some example of catalytic poison. Examples, e.g., one, you have in the contact process. In the contact process, let me talk about contact process. Go to my first video, Catalysis 1. You will see details about contact process. Okay, I will just bring it up a little bit, but details is already in my first video called Catalysis. So in the contact process that involves the oxidation of sulfur 4 oxide in the production of sulfuric acid. Having this formula, okay, the catalyst actually used to be an oxide of a transition element called vanadium pentoxide, or you use platinum. Okay, this is the catalyst used to catalyze this reaction in the industrial preparation of sulfuric acid during contact process. But the poison that can kill, that can destroy this catalyst from accelerating this reaction is called As2O3. I believe you know the chemical name is called arsenic oxide. Okay, this is what? A poison. And this is what? This one, they are what? Catalyst. Okay, I believe you can see it, catalyst. Okay, why these are catalysts? This and this, they are catalysts. Vanadium oxide or vanadium pentoxide or platinum, they are catalysts. Meanwhile, the poison that will destroy the activity of this catalyst is arsenic oxide. Okay? Now, another example I will give to you is in the oxidation of hydrogen. In the oxidation of hydrogen, where you have this is already in my second video. You can also check for details. Okay? Where you have this production, where water is produced. Here, I told you in my second video that the catalyst used to catalyze this reaction is platinum. Okay, is platinum in the oxidation of hydrogen. And the poison that can destroy this reaction is carbon monoxide. So if you put two things here, it is good for the sake of exam, you let your examiner know that this is the catalyst, and this is what? The poison. I hope you understand that. Okay. Number 3 equation, I just want to give you 1, 2, or 3 equations to support this reaction. Okay, to support what I mean by catalytic poison. It is not enough to define. You must use equation to support what your definition. Another one is in the production of ammonia, synthesis of ammonia during Haber process. Okay, what is the reaction? You have N2 plus H2 will definitely give you NH3. This is our ammonia gas being formed there. You balance this reaction, you have this. Okay, they are all in the gaseous state. Okay, so in this reaction is catalyzed by finely divided ion. Okay, this is the catalyst, and this reaction can be destroyed. The catalyst here can be destroyed when you introduce carbon monoxide. This is a poison. Please understand that this poison comes to destroy the catalyst, preventing the reactant having an adsorption on the surface of the catalyst. Okay, so this gives you the catalyst, and this gives you the poison in the Haber process. I hope you understand this, what we refer to as catalytic poisoning. So do not be confused any longer. The second one I'll be treating now is, okay, before I talk about the second one, which is the inhibitor, I just explained something about catalytic poison. I said something. These poisons, what do they actually do? Remember that the reactant, this is the catalyst, this reactant, this is the catalyst, this reactant, this is the catalyst. What happens? The reactant, they absorb on the surface of the catalyst, okay? They form a chemical bond between this reactant will form a bond with at the surface of the catalyst, okay, called the active site. Okay, this also does the same thing on this also does the same thing on this. So, but what does the poison now come to do? Instead of the reactant being adsorbed on the surface of the catalyst, the poison takes the place of the reactant. So, therefore, it will make the reactant not to have a place in the active site and on the surface of the catalyst. And when that happens, what has become the fate of the reactant or the general reaction is that it it cannot take place because the poison has destroyed the catalyst that would have caused an acceleration of the rate of reaction. So the poison is adsorbed on the catalyst surface in preference to the reactant. I believe you understand that. I will be talking about catalytic inhibitor, or simply put, catalytic inhibitor. Okay? What do you mean by catalytic inhibitor? Or what do I mean by catalytic inhibitor? It simply means a substance. Okay? Any substance that inhibits, that retards, that reduces the rate of reaction. In short, let me put it this way. Any substance that suppresses the rate of reaction is called a catalytic inhibitor. So I can say this is a substance that reduces, okay, or retards, or what? Or suppresses, okay, the suppresses the activity of the catalyst. So when a substance suppresses the activity of the catalyst, it is called catalytic inhibitor. Okay, I know you will want to know some examples and how it actually happens. So I'm going to give you some example. Example number one. Before I give you an example, when we say something reduces or retards or suppresses the activity of the catalyst, okay, it actually means that it is an inhibitor. Okay, the catalyst is functioning. The catalyst is to increase the rate of reaction, and as the reaction is very fast and you want the reaction to now be slow, you introduce an inhibitor called catalytic inhibitor. And as you introduce that inhibitor, as small as it is, the catalyst, the rate at which it makes the reaction to be fast, it will become slow. Okay? It will become sluggish. That means it is acting as an inhibitor. For example, I talked about the decomposition of hydrogen peroxide. You have hydrogen peroxide as H2O2. When it decomposes, you have 2H2O plus O2. I think it's not balanced. You have 2 here. Okay? In this type of reaction, okay, this is a reaction that on its own, this reaction is usually very fast. Okay, but if you want this reaction to be slow, what do? You introduce an inhibitor. And the type of inhibitor you can introduce here to reduce the acceleration of this reaction, to retard the acceleration of this reaction, are majorly dilute acid. So inhibitor here are dilute acid. You can also make reference to my first video you will see on Catalysis 1. You will see these details there, okay? I'm just giving a summary here. So dilute acids, an example of dilute acid you can use are H3PO4 and some other, okay? Another thing you can use is glycerol, okay? You don't need much, just little that you add. This reaction will become very slow, okay? Another example is the oxidation of trichloromethane. This is trichloromethane, okay? When it is oxidized, it's going to give us a carbonic chloride plus water and plus a gas, chlorine gas. So in balancing this, I can put 2 here. Then putting 2 here will make me to put 4 here. Putting 4 here will make this place to be 3, and then I am going to have 4 here and then 2 here. Okay, I think it's balanced now. Yes, this is balanced. Okay, this is our trichloromethane being oxidized to give us a carbonyl chloride, okay, and this. So in this type of reaction that is taking place, you can actually reduce or retard the rate of this reaction by introducing an inhibitor. And what is the inhibitor you can use here? You can use an alcohol. You prepare the alcohol, most most times 2% alcohol, okay? When you introduce 2% alcohol, okay, e.g. 2% ethanol, okay, to this reaction, just add a little quantity. What happens is this reaction will be slow. Okay, I believe you understand what we refer to as catalytic inhibitor. Well, let me say this. A catalytic inhibitor can also be a negative catalyst. I believe you understand that. You want to get the details, go to my first video. You will know what I define as negative catalyst with the equations given. Okay, there are other examples. Okay, I think these two is okay for you. There are other examples. You have anti-knock properties as a tetraethyl lead. Okay, in the as an anti-knock in petrol. Okay, but I give you this. I think this is okay for you. Okay, how does this inhibitor? What is the mechanism of action of this inhibitor to reducing the rate of the reaction? It does that by breaking the chain reaction. Okay, when you introduce an inhibitor, it reduces the reaction by affecting the chain reaction. So it reduces the chain reaction, it breaks the chain reaction, and when the chain reaction is broken, then you see that the reaction will be very, very sluggish, okay? And that is what a negative catalyst can do. I believe you understand what I mean by negative catalyst. Negative catalyst, or simply a catalytic inhibitor. The last now is the catalytic promoter. What is a promoter, or what are promoters? A substance. This is a substance, okay, which though itself not a catalyst, it's actually not a catalyst, but promotes activity of a catalyst. Okay? It's a substance which, though itself not a catalyst, but enhances, promotes the activity of the catalyst. That is what a promoter is. Okay, by definition. Okay, in place of this promote, you can use, though not a catalyst, but what? Promotes or increases the activity of the catalyst. Please note, a promoter is not actually a catalyst. Okay, it's actually a substance which, when you add it to the surface of the catalyst, it makes the catalyst to be very effective in its function. It makes the catalyst to be very, it increases the activity of the catalyst. So if you have a catalyst that is weak, for example, in the reaction, you can just put a small promoter and you see that the catalyst will, the rate of reaction will be very, very fast. Okay, so I'm going to give you an example here in as molybdenum. Molybdenum is an example of a promoter, especially in the manufacture of ammonia in herbal process. Okay, in herbal process. Okay, what is herbal process? In synthesis of ammonia, where you have ammonia synthesis. Okay, N2 plus 3H2. We have written this many times. You have 2NH3. Okay, so that is the reaction. So normally in this reaction is usually catalyzed by finely divided ion. Okay, and the promoter that can be used to increase the efficiency, the activity that can enhance the activity of this catalyst is molybdenum. So in this case, this is the catalyst and this is what? The promoter. So in the examination condition, this is how you differentiate it. Okay, so what actually happened? How do you explain the action of this promoter in this reaction? Simple. The theory behind the promotion of a catalyst, okay, is done by increasing the peaks and cracks of the catalyst. What do I mean? I mean peaks and cracks of the catalyst. Okay, that is what the promoter goes to. So the presence of the promoter increases the peaks and cracks of the catalyst surface. So when this happens, it increases the concentration of the reactant molecules, and hence it increases the rate of reaction. So with this explanation and chemical equation given, I believe you should no longer be confused about this definition. So, my fellow students, I wish you the best as you have this knowledge. Please, as I earlier told you, share this video, subscribe to it, like it, and put your comments in the comment section. Thank you. God bless you. I'm going to upload more video for your understanding.